Welcome to Math with John, Simplifying Square Roots, Lesson 1. I'll start this series with a discussion of exponents in general and square roots in particular. Let's start with some definitions and ground rules. For the purpose of this video series, let n and m be positive integers. Also, let x and y be any positive numbers. Definition: x to the n is defined as x multiplied by itself n times. X is called the base and n is called the exponent. Definition: x to the 1/2 power is equal to root x, and that's defined as the number which, when multiplied by itself, equals to x. So root x times root x is equal to x, and the square root of x squared is equal to x. Note that there are two square roots for each positive number, one greater than 0 and one less than 0. For this series, only the positive square roots will be considered. Let's discuss some of the general properties of exponents and square roots. Equation 1 states that x to a power times x to another power is equal to x to the sum of those powers. Equation 2 states that x to a power all to another power equals x to the product of those powers. N and m can equal 1/2 as well as any integer for both of these properties. Equations 3 and 4 are just variations of the definition of square root. Basically, they are different ways of writing the same thing, and the different versions of the definition apply in different problems. Equation 5 is very useful in simplifying square roots. I'll refer to equation 5 throughout the rest of this series since it is used so often. Equation 6 is a special case of equation 5, where y equals x, and along with equations 7 and 8 are three different ways of pulling two x's out of a square root and replacing it with a single x outside of the square root. Note, equation 8 is a result of the fact that when three or more numbers are multiplied together, they can be multiplied in any order, allowing any two of them to be multiplied together first. Now let's move on to some examples showcasing these equations. Equation 9 covers some of the exponent rules as they interact with addition and multiplication. So 8 is equal to 2 times 2 times 2, that is multiplication, which is equal to 2 to the power 3 by the definition of exponent. 3 is equal to 2 plus 1 gives us the next value, so nothing dramatic there. And then by the rules of exponents, 2 to the 2 plus 1 is equal to 2 to the 2 times 2 to the 1. 2 to the 2, 2 squared is equal to 4, and 2 to the 1 is equal to 2. So this gets us to 4 times 2, which equals to 8. Now on to square root simplification. To simplify root 8 in equation 10, well, 8 is equal to 4 times 2, just a bit of factoring. So this is the first value. By equation 5, root of 4 times 2 is equal to root 4 times root 2. Then root 4 is equal to 2, so we get our final simplification of root 8 is equal to 2 times root 2. Note that the first value is root of 4 times 2, and that the final answer is 2 times root 2. This shows the result of pulling 4 out of the square root. Equations 11 and 12 show two ways to simplify root 12. Equation 11 is intentionally made longer than it needs to be to showcase the different types of things that can be done. It also shows that whether you do it by the tedious way, step by step, or by the fast shortcut way, if you are accurate with every step, then you will get the same correct answer. So for equation 11, 12 is equal to 6 times 2 gets us the first value, and equation 5 gets us the second value, since root of 6 times 2 is equal to root 6 times root 2. Then we repeat the two-step process with 6 equal to 2 times 3, getting us the third and fourth values. Be sure to not leave off the extra root 2 factor. From the fourth value, rearrange the multiplied numbers so that the root 2 terms are together, and then multiply root 2 times root 2 to get 2. This gets us a final answer of 2 root 3. Equation 12 is a faster way to get to the answer. 4 is a perfect square that divides into 12, so utilizing equation 5, we get root 12 is equal to root 4 times root 3. And then root 4 is equal to 2, so we get the final answer of 2 root 3. Equation 13 follows the same pattern as equation 12, but I made the intermediate step root of 4 times 6 instead of root 4 times root 3. Since 4 is a perfect square, it can be pulled out of the square root with its square root of 2 going in front of the square root. Either way, the key to making 12 and 13 take so few steps is realizing that the perfect square 4 divides into both 12 and 24, and pulling it out first creates a smaller number left underneath the square root. Compare equations 10, 12, and 13. All three of them end up being similar problems. Feel free to use both of the intermediate steps that are in equation 10 or either of these as shown in equations 12 and 13. The right one to use is the one that makes the most sense to you. Finally, in equation 14, 30 factors into 2 times 3 times 5. There are no perfect squares here, so it cannot be simplified. So root 30 simplifies to just itself. Thank you very much. Please like and subscribe. Have a good day.